Hello, ladies and gentlemen. Time for a little overview of graphing quadratics practice. So this is just meant to build on the skills we were working on yesterday, which is, well, graphing quadratics, which are parabolas, right? They make the U shape. And the easiest way to go about graphing these is to realize what a plain old x squared graph looks like. And so I'm going to look at 2 here. For a moment here, I'm going to ignore this. We are going to actually graph that, but a few things to remember. If it's just plain old x squared, the vertex is going to be at 0, 0, and then on either side, it's going to go up 1, and then it goes up 3, and then it goes up 5 on either side. And it makes a U shape looking like this. Okay. So that's an important thing to know of what the basic one looks like. Vertex at 0, 0, and then goes up 1, up 3, up 5. It goes up the odd numbers. And so when you are graphing your function, and it's got different things than just plain old x squared, you have to know what each of those parts do. So that's what we're working on the previous lesson. If you have a number outside here, that's going to move your parabola vertically, and plus 4 is going to make it go up 4. If you have a change inside with the x squared part, like right here, it's going to move it horizontally. Remember, it is x minus h squared, just like our vertex form. That's actually where that comes from. And so when it says plus 1, you're actually going to be going left 1. And so I'm going to take my basic graph here. Let me erase these extra numbers here. And I'm going to make it go up 4 and left 1. And so I'm going to, and I like to start with my vertex. So I'm going to take my vertex. I'm going to go up 4, left 1. So now my vertex is here. Let me erase a bunch of stuff here. Up 1, left 4. But now I can just go up on either side. Go up 1, go up 3, go up 5. So I can go up 1, right 1. I can go up 1, left 1. And then I can go up 3, right 1, and up 3, left 1 for my points there. And so now I have my actual graph here. Here. So the blue one's not the answer. That's just the basic one. That's what plain old x squared looks like. But I'm taking x squared and I'm moving it and shifting it around according to what transformations are in my function. And so this is where your final answer should be for number 2. Let's jump to one that's got some other pieces to it. Yeah, let's look at 9. So 9 here. This one has some changes to it. It has a change inside, it has a change here, and it has this negative in front. Real quick, I want you to figure out where your vertex is going to be. What's the plus 1, negative 3, or subtract 3 going to put it? Hopefully you notice that this is going to go left 1, and it's going to go down 3. So my vertex, instead of being at 0, 0, is going to be at negative 1, negative 3. So here's my vertex. And this negative out front is going to flip our entire graph upside down. So instead of going up 1, up 3, up 5, we're going to go down 1, down 3, down 5. So I'm going to go down 1, right 1, and then down 1, left 1, because the parabolas are symmetric. And then I can go down 3, right 1, and then down 3, left 1 for my endpoints here. And that's as many points as I can fit on my graph. So I'm going to go ahead and connect it up. So that's graphing parabolas. I do want to show one that has a vertical stretch on it. So let's go to something like, let's go to, we're going to go to 14. So once again, we need to figure out where our vertex is going to be. The plus 3 in the middle is going to make it go left 3. And then the plus 1 on the outside is going to make it go up 1. So I can go left 3, up 1. Here's my vertex. And then this negative 1/3, the negative is going to make it open down this way. But the 1/3 is going to take all those slopes we had, right, going up by 1, 3, and 5, and it's going to times by 1/3. And so instead of going down by 1, I'm going to go down by 1/3 of what it used to be. So I'm going to go right 1 and then down 1/3, which is about this far. And then same on the other side, left 1 and then down 1/3. And then my next one, I need to go, right, normally the pattern is 1, 3, 5. I'm going to times all those by 1/3 here. So it becomes 1/3, 3, and then 5/3. Sorry, not 1/3. It's not 3. Sorry. 1/3 of 3 is 1, and then 5/3. And so I'm going to go down a third. Next time I'm going to go down a full 1. So I'm going to go down 1 as I go right 1. So give me a point here. Same on the other side. And then I'm going to go down 5/3. So I'm going to go down 2/3, 5/3, and then over. So it's going to put me here. And then same on my other side like that. So instead of my normal slope of 1, 3, and 5, it's now 1/3, 1, and 5/3. So it's going to be wider than my other ones. And the negative does make it open down. So hopefully that gives you a feel of what's going on with the graphs. Go ahead and graph the other ones. If you want, you can check your answers actually by putting it into Desmos or other graphing calculator and just kind of see and make sure you're getting them right that way. Or you can be checking with the solutions. But get used to looking at the different transformations and getting it graphed. I'm going to leave these ones to you. You remember, if you want to get the vertex, remember x equals -b over 2a at the vertex. So you can find out what that x coordinate is, and then you can plug it in to find the y coordinate. And that's what's going on in your assignment. At the last section there, it shows you a graph, and you need to write the equation. So you're just working backwards. But that's probably what this assignment is about. Good luck.